Welcome to module 9.3, and we'll now start with the next part of the front end of the compiler, what we call as the parsing. Now, before understanding what is parsing, we need to understand what is the grammar of the language. So, like English has an English as a language as grammar, the Jack also has a grammar. So, how do we capture the grammar of a programming language? We'll have a very short introduction. But we'll try to make it very comprehensive because we need to do a project based on the understanding of this. Okay. So, now we are going to talk about the parser that you see here, right, and this is the grammar. So, let us now start with understanding grammar of an English language, for example. Now, how does so as a language we have a collection of sentences. So, how is a sentence organized in English? A sentence basically has a noun phrase and a verb phrase. So that's a rule, and we need to follow that rule. So, if we want to talk sensibly in English, we need to follow a rule where every sentence that we talk has a noun phrase and a verb phrase. So, sentence comprises noun phrase, verb phrase, and followed by a verb phrase. So, you now have something on the left side which is a sentence, and that sentence essentially produces two parts, namely a noun phrase and verb phrase. The noun phrase actually has something called a determiner, can have a determiner and a noun, right. So, determiner question means it can, you will have a determiner or you need not have a determiner, then you can have a noun, right. So, and the verb phrase will have a verb for sure and followed by a noun phrase, okay, right. So, for example, so what are so now this sentence noun phrase and verb phrase comprises noun phrase, verb phrase, determiner, noun, verb, noun phrase. Now, the noun can be like dog, school, Dina, he, she, homework. A verb can be went, ate, said. A determiner can be there, to, my, right. So, now sentence gave rise to two entities, namely noun phrase and verb phrase. Now, verb phrase again gave entity to two produced two more things like verb and noun phrase. Verb ended with went, ate, said, etc. right. So, your went, ate, said, whatever you see here, or dog, school, does not produce anything more. So, these are all called terminals, right, and the other things are called non-terminals. So, now we are seeing on the top 6 rules that you see, one for sentence, one for noun phrase, one for verb phrase, noun, verb and determiner. These six rules, one for each of this, can be classified as either a terminal rule or a non-terminal rule. A terminal rule is one in which whatever you see on the right hand side is a terminal. It does not yield to something else, or it does not produce into something else. So, the terminal rules are noun, verb and determiner, because noun leads to dog or school or Dina. The pipe stands for pipe symbol that you see here, basic where I am moving the mouse is basically stands for or, okay. So, it stops there. So, the noun, verb and determiner are basically terminal rules, while sentence, noun phrase and verb phrase are non-terminal rules. So, a grammar comprises can be represented as a collection of rules, right, and each of this rule will have a right hand side and left hand side and a right hand side. Left hand side has one non-terminal, namely sentence, noun phrase, verb phrase, like that. The right hand side can have either terminals or non-terminal, and it can be a collection of these terminals, right, and the right hand side can be the right hand side can also have terminal or non-terminal that are optional. For example, what you see here, noun phrase has a determiner which is optional. So I can say the school or just say school, right? The THE becomes a determiner, and the determiner may or may not exist for a noun phrase, right? So this is how a grammar is basically represented for computational purposes, because we have to now do some computation on this grammar. It's not just understanding of this grammar by a human understanding. There is a computer understanding of this grammar that is necessary. So we need to put it in more formal term, and this is a formal way of representing a grammar. Now the grammar for Jack basically has these 4 plus 4, 8 plus 2, 10 rules, right? 10 rules, right? And what are those rules? So as we see, a program is a collection of statements, right? It's a collection of statements, right? Now every statement, right? So let us start with simple things. I could have expressions. Your grammar can basically have expressions. For example, 17 is an expression. X is an expression. X plus 17 is an expression. X minus y is an expression, right? So now with this as a context, let us go and see. So an expression is a term followed by another term, right? If you just look at this particular part, an expression is a term followed by an optional OP term. So for example, and a term can be a var name or a constant, and a constant is a decimal number, right? Now the question asked is 17 an expression? Yes, 17 is an expression because expression leads to a term, and this is optional. So expression just leads to a term. I will not use this. Term leads to a constant. Constant leads to a decimal number which is 17. So from expression I can go to expression produces a term, term produces a constant, constant produces a decimal number. So 17 is an expression. 17 is a constant which can be a term, which can be an expression. X, is it an expression? Again, expression leads to term, term leads to a variable name, and a variable name is a string not beginning with a digit, and X is one such. So expression leads to term, term leads to variable name leads to X. So X is a constant. X is a expression. Is X plus 17 an expression? Yes, again. X is an expression. So we can just do this as follows. Right, just look at this. If I go and look at X plus 17, yes, X is an so an expression is basically a term with an operand followed by a term. As you see here, this operand followed by a term is optional, but I can put like this. Now, so let us put like expression can be a term followed by an operand followed by a term. A term can be a variable name can be X, OP can be plus, operand can be plus, you see the last one here, and then your term can be again a variable name, and this can be say 7, sorry, in this case it can be constant and 17. So X plus 17 is an expression for all, right? Similarly, X minus Y can be an expression. Expression can be a term, operand and a term. A term can be a variable name which is X, your operand can be minus, this is a variable name, and this is Y. So essentially from the word expression, as you see here, from the word expression as you see here, I am able to use these rules to finally arrive at x minus y, right. So that means this x minus y is an expression, right. So this is how the grammar is basically captured. So when I see 17, is it an expression? Yes. Why? It follows this grammatical principles. I apply rules to prove that 17 is an expression. I apply rule to prove that x is an expression. I applied rules to prove that x plus 17 is an expression. X minus y is an expression, right. So this is how a grammar is captured. Now let us go and look at the next example. Let x is equal to 100. What is this? This is a let statement. Why it's a let statement? Because a let statement has a let command. Yes, this also has a let command followed by a variable name, and a variable name is a string that does not begin with a digit. That's not, so x is 1. Then it will have an equal to. Yes, it is equal to. Then it should be followed by an expression, and you already know that a constant is an expression, because expression can lead to a single term or operand many terms, but that is optional because you have a question mark here. So expression can lead to a term can lead to a constant can lead to a decimal number. So 100 is an expression. So this let x is equal to 100 exactly matches or the rule of let statement, and hence let x equal to 100 is a let statement which is grammatically correct, right. Now let us go and look at the next one. Let x is equal to x plus 1. That is also a let statement, because initially I have let, then I have a variable name which leads to a string that does not belong to x, that does not have a digit to start with x. Then there is an equal to, then there is an expression. That expression leads to a term, op term. In this case I will use one op term here because this is optional, but I can use one surely, and the term can have a variable name, op can have a plus, and the other term can have a constant. So x is equal to x plus 1. X plus 1 is an expression and it matches here. I have already seen x plus 17 was an expression, as you see here, right. So yeah, x plus 17 was an expression. Similarly, we just see that x is, as you see here, x plus 17 was an expression. So x plus 100 is also an expression. X plus 1 is also an expression. Now let us see, while n is less than lim, let n equal to n plus 1 semicolon. This is grammatically wrong, because while agrees, this agrees, this symbol agrees, n is a identifier, right, and n is a variable name, and variable name is an expression, already we know. Then so n less than lim, is it an expression? Yes, it is an expression. Why n less than lim is an expression? Because, so let us again see this. Expression is expression term. So term, op term can be a variable name, and the op can be less than, as you see here, and this term also can be variable name. So this variable name can be n, this will be lim. So n less than lim, as you see here, can be derived from expression. So n less than lim is an expression. So there is no problem here. Then you should see a braces. You don't see a braces here, right? So there is an error, right? So this particular statement, while n less than lim, without that braces, let n equal to n plus 1, does not adhere to our grammar. So this is grammatically incorrect, and that is why we get a syntax error. So when you compile a C program and you missed a parenthesis or brace there, then it gives you a syntax error, right? So this is a syntax error. This is a syntax, essentially means grammar. Syntax, the word, essentially means grammar. So there is a grammatical error here. Now let us see this. If x is equal to 1, let x is equal to 100, let x is equal to x plus 1 n. This is a very interesting thing. Now let us see, if yes, if it's a statement, then if coincides, then the open parenthesis x equal to 1 is an expression, because expression is term op term, x is equal to 1 is an expression, correct. Again, so expression is term op term, right, and this is variable name, op is equal to, this is another variable name, sorry, this is another constant, this variable name is x and this is 1. So, from expression I can derive this x is equal to 1. So x is equal to 1 is an expression. Then you should see, as you see here, a close parenthesis and you see a close parenthesis. Then you see an open braces, you see a braces. Then you see statements. So, what are statements? Statements can be statement star. What do you mean by statement star? It can be 0 or more statements, right. If I put a question, that means it is optional. It can be or it need not be. But if I say statement star, then essentially means 0 or many statements, right. 0 or many statement. This is a plural statements is 0 or many statement. Now let us go and see how this works. Okay. So I have statements. This can be 0 or many statement. So let us say this is 2 statement. Right. Since I have a star here, I am moving the mouse there. I can put 2 statement, and each of these statement, as you see above, there is a rule for statement, can be either if statement, while statement, or let statement. So in this case, each of them is a let statement. And from a let statement should have let followed by variable name equal to then an expression followed by semicolon. Similarly for that let statement. So this let, this will become x, this expression can become a term, term can be a constant, and a constant can be 100. So let x is equal to 100 semicolon is basically derived here, as you see here, right, 100 semicolon. It is basically derived. So similarly for the other let statement, I can derive let x is equal to x plus 1 semicolon. After so this statements complete. Statements comprise 2 statements, each statement is a let statement, and then that you derive. So let x is equal to 100 is one let statement, x is equal to x plus 1 is another let statement. After you finish this, you need to have another parenthesis here, the braces, close braces here, which you have, right. So essentially this agrees. So this is how the grammar is captured, and something goes error in this grammar, like what you see in the third instance here, where I missed a parenthesis, it is immediately caught as a syntax error, right. So this is how from a basic English language where we have a grammar, a computer language like Jack also has an equivalent grammar, right. So and the grammar is basically expressed as a set of rules. A rule basically has a left hand side which derives the things on the right hand side. The right hand side has either terminals or non terminals. If the right hand side has only terminals, then that rule is called a terminal rule. You don't progress, there is nothing more to proceed after that. If the right hand side has non-terminals, then at least one non-terminal, then it is called a non-terminal rule, because beyond that we can keep proceeding. And this is a subset of your Jack grammar, which basically covers a majority of the things. So, what is the next step? We have to go and find out whether your tokens that you have created basically agrees with your grammar. You have given a lot of tokens, now we have to agree with your grammar, right. For example, while lim is less than 100 braces, if x is equal to 1, this. Does this agree with your grammar? Can I derive this from this set of rules is the question, right. Now, that is what we term as parsing, right. So, what we have done in this particular module is basically we have talked about the grammar, how Jack grammar evolves from an English grammar, and how we can go and test whether a particular input program adheres to the grammar of that language, right. We are given some examples and we are taking it. So, now to what we will do in the next module is what we call as parsing. What is important about parsing is that the parsing will actually tell you how to write a program which will basically implement whatever we have described as a part of this module. So, what is the automation that we can do, so that given a grammar and given an input, we need to go and find out whether this input actually matches the grammar. If it does not match the grammar, then there is a syntax error that we need to report, right. So, we will again meet in the next module.